Notes cover rational exponents. So remember what we learned last class is that if you have some fraction exponent, so x to the power of 1 over n, that's actually equal to the nth root of x. And we can actually extend that idea. So say we have a fraction with a numerator, so x to the power of m over n, then we still get nth root, so that's the nth root of x. And because there's a numerator, raised to the power of m. And the order here actually doesn't matter. So you could also do x to the m and the nth root of that. And the reason for that is that if you have x to the m over n, that's just like having x to the 1 over n to the power of m, right? So x to the 1 over n we know is the nth root, so we just raise the nth root to some exponent power. So see that in action. We're going to switch the form in all of these. So x to the 1 over 6, we apply that rule, and we get this is the same as the 6th root of x. Or writing in exponential form, the 5th root of z means z to the power of 1/5. Power of 2/3 means that we have the cube root of x squared. Or the cube root of x squared. So those are the same thing. Sometimes it's easier to take the exponent first, and sometimes it's easier to take the radical first. So the 5th root of b to the 9th, again, we just have b to the power of 9 over 5. So these last two say evaluate. That means we want to know what the actual numerical answer is. We have 81 to the power of negative 1/4. So remember, if we have something raised to a negative exponent, so anything to the power of negative, this is 1 over, and then we change the exponent to a positive. So 81 to the negative 1/4 is equal to 1 over 81 to the 1/4. And we know 81 to the 1/4 is the same as the 4th root of 81, and the 4th root of 81 is 3. So this is 1 over 3, or 1/3. Last one, same idea. 16 to the negative 3/4 is going to be 1 over the 4th root of 16 cubed. And the 4th root of 16 is 2, so that's 2 cubed, and 2 cubed is 8. So the beauty of being able to write radicals as exponents now is that it can actually make simplifying a lot easier. So the 4th root of 27 divided by the square root of 3, it doesn't look like something that's normally something you can simplify. But now that we know that we can write exponents, or that we can write radicals as exponents, it allows us to use the properties of exponents to simplify. So we have the 4th root of 27 over the square root of 3. So one thing to notice here is that 27 is 3 cubed. So I'm going to change this to the 4th root of 3 cubed divided by the square root of 3. And now I'm going to convert both of them into rational exponents. So the 4th root of 3 cubed is 3 to the 3/4. And the square root of 3 is 3 to the 1/2. And we know that when we divide numbers that have the same base, so here we have 3 and 3 are our bases, that means we can subtract the exponents. So 3 to the 3/4 minus 1/2. That's 3/4 minus 1/2, which is 1/4. So this is equal to 3 to the 1/4, or the 4th root of 3. So we'll use the same example to simplify this one. For reasons that will become clear later, this problem has a lot of 2's, so I'm going to change these to x's. So let's say these are both x. All right. So it helps one thing. Just like we did here, we changed the 27 into 3, like 3 cubed. Here, 4 and 8 are both powers of 2. So let's write them both with an exponent of 2. So this is 2 squared and x to the 4th divided by the 6th root of 2 cubed and x. So now let's convert these all into rational exponents. So we get 2 to the 2/6 and x to the 4/6 divided by 2 to the 3/6 and x to the 1/6. And now I can take my numbers with the same base and subtract the exponents. So 2/6, 2 to the 2/6. So 2/6 minus 3/6 and x to the power of 4/6 minus 1/6. Let's put these exponents in parentheses. So 2/6 minus 3/6 is negative 1/6. So we have 2 to the power of negative 1/6 and x to the power of 4/6 minus 1/6 is 3/6. But since this is 3/6, so 3/6 is going to simplify to 1/2. And now, just changing my exponents back into radicals and moving my 6th root into the denominator. So we're going to get the square root of x divided by the 6th root of 2. So we can see how being able to convert these into rational exponents allowed us to use these simplification properties that work on exponents. And we turned this expression that had 6th root of 4x to the 4th, and that all simplified down to just 1 square root of x, which can be useful for dealing with expressions that kind of look nasty to begin with. All right, that's it.